Hello maths fans, and this is some help with a Maths Watch clip that was set as part of an assignment for Year 9, and that was the week beginning the 27th of April, and it's question 19 that we're looking for here. So if you've looked through here, this is to do with loci, and loci is more than one, that's the plural. A locus is a set of points which follow a particular rule, okay, or law here. So in this case, we want all the points which are the same distance away from A and B. So that we want the locus, the path of all the points which are the same distance from A as from B. Okay, now you may have seen this video, you may not have recognised what's going on here with this, but you need your compass, okay, and you set it to over the half the distance of A to B. Now you can actually measure it and do that if you like, but you don't need to measure, okay. Now, so what I'm going to say is, you don't need to measure. I'm just going to do over half here. I'll show you why that has to be over half in a minute. I'm just going to draw a circle at A and B, so that's going to be no good, okay, and you'll see why in a minute, okay. So we'll get to A, and I'll set it over half the distance, and I just draw a circle. Now you can go the whole circle, there's no harm in that, you won't need all of it. Whoops, I'm sure we all have these problems sometimes. Okay, we don't need all the circles, it's very hard because I've got the camera in the way here as well. Okay, so that's A. You'll see why I don't need all of it, because all I'm really interested in is the intersection point. So I've moved my compass, not affected the compass point, I've not affected the radius of my compass, i.e. that distance there. Move to B, and we do the same. Now once I've got those intersection points, I can stop that circle, I don't need it anymore. Okay, so what do I know about these 2 points, these intersection points I just talked about here? Well, because I've used the same radius on my compass, we know that that distance there is the same as that distance there. Okay, these two distances are the same. And similarly here. So we know that these points here are the same distance away from A as they are from B. The same distance away from A as they are from B. Okay, now I could repeat this 100 times with different. I'm going to do two more. You don't need to do this many, but I'm just going to to show you how this works. Okay, watch what happens now. I'm going to make it slightly bigger, my radius. I'm just pointing out you don't need to do this, but I'm just showing you what will happen here, so you can understand it. Move to A, sorry, and do that again. You will now see I've got an intersection here with those two arcs and here. And what you're starting to see here, if I put my ruler here, is a set of points. Okay, slight inaccuracy there by the looks of it, but a set of points which fall on a straight line. And I could carry out this an infinite number of times and basically join this up, and every single place I'd find all the points on this line then. Which means this line must have all the points which are the same distance away from A and B. Now if you don't believe me, you can try one. Let's just try a point there and measure from A to A. And I've got about 6 centimetres, hope you can see that. If I now measure to B, I've got 6 centimetres. Very clever, don't even need to measure. Do not even need to measure on this, okay, to get this locus. Okay, so going back to the start again, it needs to be over halfway, otherwise we won't get the overlap. Look, what happens if I do less than halfway? Watch what happens. I get a circle here. And a circle over here. Well, they're never going to overlap. I think you can see that, okay? So over halfway, and you only need to do it once. So these were the two original ones. You need 2 points in a straight line. And you don't just join them up, okay? You don't just join them up. You carry on to the edge of the page because it wants all points. And if you stop here and here, you don't get all points. Okay, now that is known as the perpendicular bisector of line AB. And the reason for that is, now you've done this, if I join A and B, you can see it cuts A to B in two. So this line here, let's call it X. A to X and X to B are the same length, and it cuts it at right angles. Okay, clever little bit of maths, little construction there. Okay, I hope that makes sense, and I will see you next time.